Hello, everybody. Then, how are you guys? So, um, we're glad you all are here. We'll probably wait for a couple of more minutes before everyone gets on the boat. This session is about introduction to Hashicorp Vault. So obviously, we are deep diving into security and governance part of the infinite loop of DevOps. Um, Before we move ahead and Imanshu gets on with the session, um, it's always good to know that how we manage secrets for multiple environments. Let us say you have a branching strategy which allows you to have parallel development, and then you have multiple environment like staging, pre-prod, and then you have a release branch, then you have a production branch, right? So it becomes very insecure um, to manage secrets, or let us say you do not have a jump server, right? Then it becomes painful, right? To manage dynamically our secrets. So as I said, moving into the second governance part of our CICD maturity, it is important for us to look at tools which allow us to use uh, secrets securely. They are encrypted at rest, and they should be encrypted on the fly as well. So Hashicorp Vault is one tool which can easily manage these secrets for you. And best part is, I think Imanshu will cover up that topic, that you can dynamically uh, use them and rotate them again, being encrypted and in a secure way. So again, thank you all for joining. We'll probably pass the baton to Himanshu. Sit back, relax, and let's learn something about Hashiko World. Happy learning, guys. Over to you, Himanshu.
Yeah, thanks, Rahul. I hope my screen is visible, right?
Yes, Imanshu, it is visible.
All right. So, hi guys, welcome to the today's session. And today we are going to deep dive and discuss over Hasiko Vault. And so, my name is Himanshu Chaudhary, and I am a software consultant here in the Nordus. So, let's look up first the knowledge etiquettes that we must follow. So first one is the punctuality. Punctuality is like we should join the sessions on time or even though before 5 minutes. And then we should keep silent until and unless we need to ask question or to discuss something in the on the sessions. Then we should avoid disturbance and then make sure to give feedback on the knowledge portal. Okay, so our agenda is today about what is Vault, features, use cases of Vault. Then we will look into the Vault CLI and the Terraform provider that we have. Alongside, we do have the APIs to interact with Vault. And then we will see the demo, like how we can manage the Vault as an admin, and then how we can retrieve secrets from the Vault as a developer or as a DevOps. All right. So first of all, we are going into what is Vault. So Vault is an identity-based secret and encryption management system. So what identity-based means, suppose you are a developer, then you basically going to authenticate Vault to get the secrets. Then in that case, the Vault basically identify yourself and then provide the token to you on the basis of policies attached to your secret, and then you can easily get the secrets for your database, for your applications, for your deployment pipelines from the Vault. Along with that, it basically track all the requests, basically it do a audit based logging. So whatever things you are performing, it basically keeping track of everything. And going to the encryption management system, so Vault basically encrypts secret at rest. So uh, we will be like going focused on architecture diagram, like how it basically doing that. um, we have several components that basically helping in achieving this encryption management system in Vault. Now looking at the secret, so what secret is? So secret can be anything that basically tightly control access to, such as we have database credentials, we have SSH keys, we have certificates, which basically we use in internal cloud, or we can say in internal infrastructure. Then we have passwords, etc. So Vault basically provide encryption services that are gated by authentication authorization methods. So you all know what authentication authorization. So authentication, it means uh, how a user get authenticated using a username and a password. And then authorization is just to validate whether a user is authenticated or not, to view that page or to view that credential or not. So we can use Vault UI, CLI, we can use HTTP API to access secrets and other sensitive data on from the Vault securely. And uh, it basically are tightly controlled and restricted. We should more focused on security when we are going to use Vault, right? So coming up to the Vault, so this is all about Vault. Then there is one more thing. If you are not able to install Vault, or not able to start on it, or like a quick start way, so Hashicorp Vault has a hosted version of Vault as well, which is known as SCP Vault. So you guys must try that. They have a free trial, like they give a $50 free credit to use the hosted Vault. So just I'm going to show you a small glimpse of that. So here's the SCP Cloud Vault. You can simply go and sign up with your account, and then you simply log in into the Vault. Is asking for a one-time security password. So it's nothing. It's just a Google Authenticator that I've attached, which is necessary. So here's the console look like. You have to select, you have to attach your organization while you are logging. Then you can simply initialize your Vault by just clicking on create the cluster, and then you are good to go. Then it will provide you a basically a URL and the credentials, the root credentials for your cluster, and it's very easy to start. All right, let's like a deep dive into the architecture diagram. So the Vault architecture diagram basically divided into three parts. First one is the HTTPS API. Then the second one is the barrier, which basically contains all the core component of Vault. Then we have a storage backend, which is not part of a barrier, barrier component or a barrier part, because we should use a separate storage to store our secrets, right? So storage backend can be uh, a file system for your instance, or um, for your system as well. You can use in-memory database, you can use cockroach db, you can use uh, GCS, Google Cloud Storage, you can use Cloud Spanner, you can use uh, S3. Like there are lot of options to select between the storage. And then if we're talking about the HTTPS API, it's basically provide an interface to interact with the Vault. And so I think all of you know about what is the APIs, right? Anyone can explain what is API in a common way? All right. Um, so API is just an application program interface, which basically we use to interact with our application with the help of the various various routes. Even we can uh, integrate the Vault APIs in our application to get secrets directly, but it's not a best practice. You should avoid integrate the like Vault API directly into your code. Now coming up to the core components, the main barrier components. So we have a core, a token store. Like you will see a lots of components, and each one have their own functionality and their own working. Right. So coming up to the core. So core component is just a gateway which basically interact with the HTTPS API and the path routing. So core component is basically the place where your API interact with actually. So you basically don't interacting with the API, but you actually interacting with the core. Then when you hit API, it basically checked by a token store. So whether you have a valid token store or whether it's expired or not. So expiration manager basically manage the expiration of your token. Then after your token is authenticated and checked whether it's expired or not, then it will check the policy attached with your token. And once it verified, then it will route you to a specific or a particular secret engine, whether you are like which secret engine you are using and what policy attached with your token. Then it's have a auth methods. So auth method basically check like which through which authentication mechanism you are using, whether you are using credentials for username and password, whether you are using SSL, sorry, not the SSL, but the certificate keys and the PEM files, whether you are using a GitHub authentication, and like there are a lot more authentication method Vault provide. Now, system backend is just basically used to interact with the storage backend. So it basically store the secrets in the storage backend encrypted at rest. So you don't have to worry about the encryption and decryption of this storage. So if someone get the backend, but he or she like anyone don't able to decrypt them because they are encrypted by the Vault in a very like in a very secret way. So you don't have to worry about the storage backend. Coming up to the audit brokers and audit devices, again the audit devices. So these are basically like what I say, the audit logging. So they basically track each um, each request and the secrets and responses that going out and in from the Vault. So they basically track everything. So let's say if someone has deleted the secret from the Vault accidentally, or maybe you can say by intentionally, so we can easily track him or her using the audit brokers and audit logging and audit devices. So that's a big picture of architecture diagram for Vault. So if you have any doubt, you can ask.
So what are secret engines?
Okay, yeah, my next thing is about secret engine. Like we are going to deep dive into the secret engine as well. Anyone has any question, or shall I proceed? All right, I'm taking it as a no. All right, so what actually a secret engine is? So secret engine are basically the component which store, generate, and encrypt data. Okay, so we have a lot of secret engines like in the Vault. We have a key value. We have a databases secret engine, Transist, SSH, time-based OTPs. We have GitHub, JWT, OIDC, PKI certificates. So there are lot of secret engine that Vault provide, right? So if we are talking about secret engines, so they basically provide a mechanism to interact with a particular we can say a backend, a particular backend, right? So let's say you are using AWS, right? You have access keys and secret keys, right? So whenever you have to authenticate a new user, you have to go to AWS console, then you have to create secrets, then you have to attach the roles, you have to attach the policies, and then you have to give back them those secrets, right? But if you are using Vault secret like Vault, then you don't have to take care of that. You just provide your the IAM role secrets, and then uh, you can authenticate Vault with your AWS access key and secret key. Then just create a user, then attach the policies from directly Vault. Then it will automatically create the user and attach the policies on IAM in the IAM console, right? So you don't have to go every time to the console and then generate separate secrets for the AWS access, right? So this is how this is the secret engine of AWS, which basically used to interact with the AWS IAM roles and IAM users. Along with that, we do have like other secrets like databases. So with the database secret engine, we basically generate generate these secrets in a dynamic ways. Let's say let's take an example. We have a Kubernetes, we have a microservice or an application running on Kubernetes, right? It basically have multiple ports. One, let's say you so we basically install an agent, Vault agent, which basically take care of um, every pod. Let's say you created a new microservice which basically need to authenticate to a database which already stored in database secret engine, right? Let's say you have a PostgreSQL or a MySQL. So whenever a pod created, a new secret is automatically created by the database secret engine, and then it basically inject that secret into database which already we provide credentials for in the Vault, and then your pod basically pick that secret and start transactions between database and your application. And whenever that port is going to be deleted, as we have the ephemeral ports, right? So this it basically trigger again the secret engine and delete that particular temporary or dynamic secret from the database as well as from the Vault. So these are the functionalities. So you can take them as a plugin for each provider or for other services or databases or anything that you want to use. So this is how secret engine is important in Vault. So any questions, guys? All right, then moving forward, we are going to some of the features. So the key features for Vault are basically to secure secret, like it basically provide a secure secret storage, because it basically encrypt your secrets at rest. So this is one of the feature of Vault. Then we can generate the dynamic secrets, like just I have discussed about how we can generate database credentials for a particular pod dynamically and then remove them automatically with the help of Vault agent and the Vault server. Then it basically install all the it basically help in data encryption without storing the secrets into the Vault. So I think you all aware about the if we have an application and we want to let's say encrypt our data, right? Encrypt our data from like whether from the UI to the backend or whether from a developer to a like directly interacting with the API, right? So it basically encrypt that data at um, without storing those secrets into the Vault. So this is one of the major feature of Vault as well. Right. Then we have leasing and renewals. So let's say if you want to provide a leasing time, let's say I have created a token for a developer and I only want that developer to access only for 2 hours. Then I will attach a leasing policy or a lease time to that token, and as soon as that token expired, like he or she will not able to access that secrets again. Then we can easily renew our secrets like the Vault authentication secrets as well as the other application secrets as well. Then we can revoke at any time, whether it's a security concern or whether a leak of a secret. We can easily revoke secrets from Vault with just a single command. All right, coming up to the use cases. So so there are tons of use cases for Vault, and some of the use cases are listed here. One is the general secret storage. As we know, the feature of secure secret storage, this is also the same general secret storage. We can store secrets in a key value pair, right? But just using a KV secret engine. Then we can set up the dynamic secrets. Then we can set up the Kubernetes secrets. I just told you with the help of Vault agent that we installed in our Kubernetes cluster. Then we can easily rotate credentials. Like what credential rotations means, let's say we have a database that we are using. So let's say the policy for the client or for the project is you need to remove the old credentials in every 1 month, and then you have to recreate the credentials, and then you have to re-authenticate for the database. So credential rotations helps there. You don't need to like go delete and create again these secrets. You can just simply help with Vault. It basically help just attach a lease time to that credentials and then renewal time. Then it will automatically rotate your credentials and inject into the database as well as into the application. Then you can easily generate API keys, and data encryption is like another one of the feature of the Vault. Okay, so coming up to the Vault CLI. So Vault basically provide these following ways to interact with the Vault. So you can interact with the through the CLI. You can interact with the Terraform provider. So second one is the basic, like as this is the Hashicorp product, so they definitely give the Terraform provider. Then third one is we can interact it with the APIs. So let's go up into the demo directly, then we will see everything in the demo. All right. So right now I don't have my Vault cluster up. We can just simply check Vault status. So what I'm going to do, I'm just setting up a cluster first. So for that, I'm going to use a vault.scl file. So it's a basic simple Hashicorp a Vault file, which basically using a backend, a storage backend as a file, where I'm storing it in the temp Vault data, and the node ID is node1. I am giving node ID as node1 because suppose I have to deploy one more node, so it basically the node ID should be changed for every node. So I'm using it as a node1. Then listener is TCP. So I am basically listening all the connections at address like at all the address on 8200 port, and I am like this is a TLS cert file that I've created using the OpenSSL command, and this is the key for that certificate. So I'm basically securing the Vault using the certificate files and key. Even though you for the startup you don't need to set up these, you can just simply attach a flag which is TLS enabled equal to false. Then this is the same, the API address to interact with our Vault. And then this is the cluster address. And I'm going to open the UI to show how cool we can even we can store secrets using the UI. So let's get started quickly. So to start a Vault, I'm starting it in an interactive way, not just in the background. So okay, Vault server config vault.scl. So it has been started, but initially it is in the shield state. So Hashicorp or like Vault or Hashicorp basically used a Sami's secret sharing algorithm, which basically have which has a root key, which basically created with the constituent of 5 separate keys. So let's go and just initialize the vault. So for vault, to initialize vault, we just write command vault operator init. All right. So before initializing, I need to export the self-sign certificate as well as I need to export the vault address. So I am going to use a variable. Right. So I'm basically exporting vault address. Vault skip verify is true because I don't have a valid certificate. So I need to pass a key to the true so that it won't check the certificates. So I'm going to export this variable and just do vault init. All right. So when you init, it will give you the 5 unsealed keys, which basically constituent and make a root key, which basically used to unseal our vault. So let's copy this and should save them in a secure place so that we can use them again whenever our vault node is down. Even we can automate these steps, but this is not in the scope right now. So I'm just simply going and unsealing the vault. So for unsealing the vault, you can do vault operator unseal and then just paste 1. So you see, if you check, the shield is true right now and it's using the Sami algorithm. We have already initialized with this, and right now the unseal progress is 1 of 3. So we need to provide 3 keys to unseal the vault. And again, you can give the keys in any order, whatever you want. I am giving the third one. Right, so it's been shield is equal to false, and we can again check the vault. It's so shield is false, and then to more verify, we can run vault auth list. Right, I'm not authorized yet, so I have to log in into the vault. So to do the login into the vault, you just do vault login. And then provide the root token. All right, it has been authenticated, and we just do vault auth list. Then it will. So currently we have only one authentication method, which is token, and so these are the vault command. There are a lot more. You can list the secrets. You can list the policies. You can list the authentication method. You can list the secret engine. So by default, there is only one secret engine that is enabled. There are 3. Sys is basically used to contains all the vault information. Then there is one more identity, just we said, vault always keep track of your identity. Then there is one default pre-token private storage that vault give you. So to enable a secret engine, you just type vault secrets enable, and then you can type the secret engine name. So I'm doing AWS, and then if you see vault secret list again, then AWS secret engine has been enabled. Then you can just use the your access key and secret key and put them into the AWS roles in the vault, and then you are good to go over there. Okay, so these are about the vault CLI. You can use more. Let's move forward to the Terraform. All right, so this is the vault provider, and I'm using the vault version of the vault provider version of 3.4.1, and I have the Terraform version of 1.0.0. So these are the important as per the Terraform, because let's say if you are working on the oldest version and by accidentally you install the latest version of Terraform, then your state file is going to be stuck because you don't you won't be able to roll back to the previous version, and maybe it maybe happen like you have a breaking changes in between the two versions in 0.15 or 1.0 or any other version. So it's the best practice to put the required version variable into your Terraform configurations. And then we are going to use Vault provider. I am not passing these things in the Vault because it's not a good practice to share secrets in the Vault scripts. So I am basically going to export these environment variables, which I already did, and then going to apply these things into the Vault, right? So these basically give the Terraform the information to which Vault server we need to connect and to using which Vault token. Then I'm going to basically enable the user pass out method, which has the max list time of 120 seconds, which is 2 minutes. Then I'm going to create these following roles. We can say the authentication users, a developer, which is the developer, then stakeholders, and then the admin. So these the script are basically for the admin purposes, who basically create the secrets, and these scripts should be stored and should not be stored on the we can say on the source code versions, or we can say on the Git or Bitbucket. So this should be stored in some the secure place in the organization. So for some advantages, there are some disadvantages for Terraform as well. So this is the one disadvantage about the Terraform Vault provider. Then we are going to attach these policies, admins, staging, dev, which I've created already. And these policies are coming from these files, admin policy.scl, tab env policies, and staging. So if we are talking about the policies, so I'm just creating an admin role because according to the best practice of Vault, you should revoke your root token and should create an admin user, whether with the help of token, whether with the help of a user password, or whether with the help of a GitHub. So you should revoke the root token. So policy creation and applying is very simple, even with the help of Vault CLI. You can just simply give the path of the secret engine and then just give the capabilities what you basically need to do with that particular policy. And then you can just simply attach that policy with the help of the resource Vault policy. And it will basically attach the policy to, it basically create the policies in the Terraform form. And then you can attach the policies by giving the name of that policy. So this is the basic Vault generic endpoint resource that I'm using. So it basically store the key secrets in a key value form, and it basically used to create a user in the Vault to authenticate. This is policy I will talk. So I'm going to enable a secret engine of KVV2, which basically store the secrets in a key value format. Right, so just move forward. I'm going to use this folder, just do Terraform init, as I've already export the Vault address and the token, so I don't need to do it again. Just initialize, and it will going to initialize my backend as the local, because I'm not using any remote backend. Then it is going to install the Vault plugin, or we can say a provider, into the .terraform folder. All right, I think you are familiar about the Terraform. Now we just do Terraform plan to check what are the resources are going to be added. So these all are the resources that we have created. So it's going to enable the Vault user pass, then created the some users, then create the policies, and then attach those policies to the users. Okay, before that, I'm just going to show you the UI, and we will check. Okay, so I've just created a Vault entry. the host entry into my etc.host. So I'm just created the secret over there. Okay, so it basically giving me option to log in, like which authentication mechanism you need to use to log in into the vault. So I'm currently using the root token. So let me get the root token from here. It gives a warning you are have logged into the using the root token, and it can break anything in the server. So I've just like enable the AWS secret engine, and it doesn't have anything. Then it's the by default secret engine cubbyhole. Then let's apply the Terraform, and it's been created. And if you go and refresh, then it's give the option because we already enable the user pass option, and then we can even log in with any other method. So I'm going to use the user pass, which I've already provided, created a user developer and along with the password. So I'm going to log in. Right, I've been logged in, and a new, okay, I haven't provided the policies to view the secret engine of AWS. If you check the policies for dev, I am only provided to see the secret/data/dev path. So we can fine grain the policies and the roles to a particular user in Vault. Um, I have also a staging path, but I am denying all the capabilities for that particular user so that he can only access the secrets for a development environment, let's say, right? So if we go, so right now we haven't write any secrets. We just created the users and the enable the authentication mechanism or the auth and enable the secret engine, which is KVV2, and just create the path. So let's move and write some data using Vault. So now I am acting like a developer. So I have the username credentials, which is named as the developer and a password. So I'm going to basically log in with that. So you can directly use Vault login minus method, which is the user pass and username, and then the password. Okay. Right, so it basically authenticated, and it will see the maximum time that you can be authenticated with user is the 2 minute, right? So okay, I have already set the so the best practice is you can export the Vault token without, like, not to directly log in into the Vault using console. You should use the Vault token. So I'm going to get the Vault token and saving it into the environment variable. Right, so if we do echo $Vault token, then it will give the Vault token. Now if we do Vault KV paste secret dev database, so there are no values. So I'm going to use Terraform init Terraform and right. So it basically going to write the secret, but I don't have the permission for the staging path. So it will give the error when I'm going to do apply. Okay, so it give like permission denied for the staging. Okay, so I'm going to do the Vault secret. So what I'm just using a Vault's generic secret resource for writing the data into the secret dev database path. And I'm basically using a base64 encoded value. Even you can pass it in the JSON format. So I'm just encoded that JSON format into a base64 and just provide the encoded value over here. Then to access, you can just simply create output variable and then just point the value part to the this particular vault generic secret part or the data vault secret part, and then it will fetch the particular secret with the help of a key, which is password or a username. So I'm going to comment out this because I don't have access and do it again. Okay, I think the token has been expired. I have to log in it again.
Hi, Himanshu. I'm so sorry to interrupt in between. We just have 1 minute left for the session to complete.
Yeah, I'm just commencing this, just the last thing. Right, so it has been applied. There's no changes because the secrets are already applied. I'm going to check the authenticate. And if we go dev database and the secrets are in the vault now. So this is how we can write secrets, and to read the secret, we can use the data source for the vault generic and then just grab the secret with the help of our output variable. So this is the basic introduction. How can we use Vault with the Terraform as a developer and as admin as well? So one of the important use case that I have to discuss is uh, the Vault dynamic secrets and the Vault rotation, as well as when we have multiple environments. So I have a use case for that. The project, in the project that I am working, they have 24, more than 24 environments right now, and they are basically creating more. So to manage the secrets in the in those environment, which basically has tons of services and application running. So with the help of Vault, we can easily do that, right? By just authenticating to the Vault and injecting those secrets into a pipeline, into the Kubernetes, into the databases, and then even we can rotate them easily with the help of the Vault. So this is the one of most important use case that we have with the Vault. So thank you guys. If you have any question, you can ask.
Himanshu, I have one doubt.
Mhm.
Actually, if you have two different vault servers
Hmm.
and it two different environment and it is not means sharing a common vault server, and if I want to migrate my credential from one environment to another environment, which have a two
Mhm.
different vault servers, so
Mhm.
can we do with the it's vault or it is a manual work?
Um, so for the two, so you can even write scripts. So you should follow a flow. First, authenticate with the one, grab that JSON file. Okay, one thing, you can
It
export a
is
full secret with the help of a JSON file, right? You
yes,
know that.
yes,
So
right.
just grab that JSON file and then put that into the new Vault server. So I think you have to do it manually because otherwise you have to
Yes,
re-authenticate in a we can say in a sequentially way, so that you can first get the secret from first Vault, save it, and then put it into the next Vault server.
okay, means manual work is required here, no?
Yep.
So, okay, thanks.
So any other question, guys? Anyone?
All right, then I guess thank you all for joining, and I hope you learned something today. Don't forget to fill out the feedback after this call. And thanks a lot, Himanshu, for this wonderful session.
Thanks, Himanshu.
All right, guys. Thank you. Thank you,
It was a
guys.
nice session.
Thank you, Rahul.
All right, bye.